Happy day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Today, I want to present the derivation of what is called the moment of inertia for rigid body. We want to do the proof of the general formula for the moment of inertia of rigid body. Now, before we derive the formula for moment of inertia I of rigid body, we need to understand the following background terms. The first one is rigid body. What is a rigid body? A rigid body is a solid body that consists of particles. Let's say this particular particle, another particle there, and there. Now, if there is a distance between this particle, let's say R1, and between this particle R2, the particle P1, P2, P3, for instance, between particle P1 and P3, the distance between them is constant. Between particle P2 and P3, the distance R2 between them is constant. So a rigid body is a body. This one is an example of a rigid body, which consists of these particles. A rigid body, in a nutshell, is a body that consists of particles, such that the distance between any two particles is always constant with time. Now, another term that we want to, describe is called inertia. In physics, inertia is the tendency of a body, let's say this particular body A, to remain at rest. That means body A is at rest, it's not moving. Or the tendency of body A to move in such a way that it resists being influenced by any external force. What am I trying to say in essence is that when we talk about inertia, inertia is a tendency of a body to remain at rest, or the tendency of that body to continue to move with uniform velocity along a straight line, unless an external force compels it to behave otherwise. So inertia, for instance, if you want to start a vehicle in the morning, you discover that the vehicle will jack. That means it's trying to resist being moved from that position. That is an inertia of a body at rest. Now, if the car is moving already and you apply brake, the vehicle will not stop immediately. It tends to continue to move. So the tendency of a body to remain at rest, or the tendency of that body to remain in motion, is what is called inertia. And we discover something, that inertia the inertia of a body, is dependent on the mass of that body. What am I trying to say about is that when you consider a car has a small mass and a trailer has a very big mass. So in a nutshell, the inertia of a trailer at rest is more than the inertia of a car at rest, or the inertia of a trailer in motion is more than the inertia of a car in motion. Now, we move down to the third term, which is moment of inertia. What we doing by moment of inertia of a body? Like I said, the moment of inertia of a body is a measure of the amount of turning force that it will resist in such a way that the body will continue moving. What am I trying to say in essence is this. Let's say we have this particular body, a rotating body. This body is rotating. Now, if we apply an opposing force to stop this body from rotating, the amount of turning force, this particular force needed to stop this body from rotating, the measure of that amount is known as the moment of inertia I. Now, how do we prove the formula for moment of inertia? Now, let's consider any arbitrary body, let's say consisting of different masses m1, m2, m3, and so on and so forth, at distances apart from an axis 0. Let's say m1 is at a distance r1, m2 is at a distance r2 from the axis, m3 is at a distance r3 from this axis. Now, one thing is this: as this particular body rotates about this axis, the particles making up this body, they undergo what is called kinetic energy. So the total kinetic energy of this body is the sum of the individual kinetic energy of the particles making that body. Let's say is the sum, like for the first particle is half m1 r1, there is no half mv square 1 plus half m2 v2 square plus, and so on and so forth. So we can represent this summation of individual kinetic energy as the total kinetic energy, which is summation half mv square. Now, in my other video, I discussed what is called angular velocity. Angular velocity is talking about the velocity of a rotating object. Now, angular velocity v is given as linear velocity is related to angular velocity. So linear velocity v is angular velocity times radius about which the body is rotating. Let's say we have a circular path that this body is moving along. Let's say body of mass m. This is the radius of that path, circular path, and this is the linear velocity. The angular velocity is the velocity with which this angle is moving with respect to time. So the relationship between the angular velocity and linear velocity, like I said, is that this linear velocity is angular velocity times radius of that circle. Now, if you substitute this parameter in the formula for kinetic energy of a rotating body, we can have that the kinetic energy of a rotating body is given as summation half m brackets wr raised to power 2. This particular wr is the velocity that we have in that formula. Now, if you open this bracket, we have summation half m omega square r square. And then for the rotating body, this angular velocity is a constant, and this half 2 is a constant. We can bring these two parameters outside this summation sign. So we have omega square all over 2 summation mr square. This summation mr square is what is called moment of inertia, moment of inertia of a rotating body. So this particular parameter, moment of inertia I, is mr square for rotating body generally. Thank you.